Hi viewers, I am Yellesh from Apex Institute of Maths and Sciences. Today I am here to explain about worksheet related to ninth grade gravitation. In the previous session, we have discussed about the content and the concepts related to this gravitation. So today let us discuss worksheet related to this chapter. The first question, the value of the universal gravitational constant. The value of universal gravitational constant. What happens from place to place? As we know that does not change from place to place. Means the value of a universal gravitational constant remains same at any place in the universe. So answer is B. Next, two iron and wooden balls, means one ball made up of iron and the other ball made up of wood. So two iron and wooden balls identical in size are released from the same height in vacuum. The time taken by the to reach the ground, means what is the time taken by them to reach the ground, means will both reach at the same time or they reach at different times. Here we know that the gravitational force is independent of mass. Hence, even though both the balls are made up of different metals, one is iron and wood, both will reach at the same time. So they reach exactly equal. So option D. Next, the value of G is maximum. So on the earth, where the value of G, acceleration due to gravity, is maximum, is it maximum at poles or is it maximum at equator, or will it be same at all the positions? So generally, if you observe the shape of the earth, as we know that we say the earth is spherical in shape, but at poles you will see it is slightly flattened. At poles it is slightly flattened. So due to that, if you observe the radius from center of the earth to at the equator and from center to the poles, this r value will be less than r. So due to that, we will be noticing that there is a slight change in the acceleration due to gravity. So it is maximum at poles. So it is maximum at poles. Next, if G is gravitational constant and r is the radius of the earth, then acceleration due to gravity G and the mean density of earth D are related by the equation. Means he is asking us to just identify about the relationship between G, D and also with a small g. So to identify about this, first we should know the relationship. You can see the formula here. According to our concept, acceleration due to gravity G is equal to G into m by r square, where G is called as universal gravitational constant and m is the mass of an object and r is the radius or distance, we can say. The next, this taking the mass as a formula, we know that mass is equal to, means generally we know density is equal to mass by volume. So as we want to require mass, so mass is equal to density into volume, where volume expressing volume of a sphere, where volume of a sphere we know that 4 by 3 pi r cube. So into D, as D is there, so this is the value. Under the simplification, you get D is equal to G by G into 4 by 3 pi r. So here if you see the answer, this will be the related answer, where G by G 4 by 3 pi r. So this is the option B. Next, if the earth stops rotating about its axis, the acceleration due to gravity will remain unchanged at. So, if the earth is stopping its rotation, as we know the earth rotates on an axis. So, if it gets stopped on its axis, where the acceleration due to gravity will not change. As we know that the point of axis is same at poles. So, for that reason, you can say it will not change at poles. Means the G value will not change at poles even the earth stops its rotation. Next question. The potential energy of a satellite of a mass m and revolving at a height r above the surface of the earth, where RG is equal to radius of the earth is, means he is asking about the relationship between the potential energy. So to identify about that, you can see the solution as we are given here. The gravitation potential energy U of a satellite is in orbit of a given by the formula U is equal to, where U is nothing but called as the potential energy, G into capital M small m by R. So to express this potential energy in the terms of acceleration due to gravity, we have to use the formula G is equal to Gm by R square. So substituting this G value in this, you will observe U is equal to Gm m by R, where R is equal to 2 RE, means that is twice the radius of the earth, since R is equal to twice the radius. So this can be expressed as, by simplification you can observe 1 by 2 GMRE, means half of the value. So you can see the answer is mgrg by 2. So that is the relationship between the potential energy when the mass of a body, revolving body, and at a certain height. So next question. The planet revolves in an elliptical orbit around the sun. The semi-major axis, semi-minor axis are A and B. Then the square of the time period T is directly proportional to, means if the planet is revolving in a, if you take this is the center of a sun, and we know that while it is revolving it lies at one of the foci, then this is called as a semi-major axis, and if you take this is a minor axis, and here we know that the major axis is given by A and the minor axis is given by B. So what is the relation between the time and these axes? So this is given by using the formula T square is directly proportional to major axis cube, means the square of the time is directly proportional to the cube of major axis. So the answer is T square is proportional to A cube. So here you can see the answer A cube. Next, the escape velocity of a body depends upon mass, as we know the escape velocity is independent of mass. So as it is independent of mass, why? Because we know formula of escape velocity is root 2gr, where in this formula you will notice there is no mass at all. Hence we can say that it is does not depends upon the mass, so we take the value as m power 0. So the escape velocity of a body depends upon the mass as m power 0, means it doesn't depend upon the mass. Next question. The time period of an Earth satellite in circular orbit is independent of, means the time period of an Earth satellite, means a satellite which is revolving around Earth. A satellite which is, if you take this is the Earth and this is the satellite which is revolving around the Earth. If it is revolving around the Earth in a circular orbit, is independent of, it is independent of what factors? So here you can see the formula, the time period of a satellite is T is equal to 2 pi into root over R plus H whole square by G into M, where M is the mass of the earth. So hence, here you can say what it is independent of mass of a satellite. Here we are not using any mass of the given satellite. Hence it is independent of mass of the satellite. Next question. For a satellite moving in an orbit around the earth, the ratio of kinetic energy to potential energy is. So what is asking here? A satellite is moving in an orbit around the earth. So what is the ratio between its kinetic energy and potential energy? So to know that, first let us see. This is the expressions which we have to discuss. The potential energy of a satellite of a mass m at a distance from the center of the earth of a body is given by the formula U is equal to G into capital M small m by r square, where m is the mass of the earth and small m is the mass of a satellite if you take. Here G is the universal gravitational constant, and if you consider about the negative sign, it is nothing but it indicates that the energy is bounded to the gravitational field. The next, when you go for the kinetic energy, for a satellite moving in a stable circular orbit of a radius r, the kinetic energy is given by K is equal to half mv square, means kinetic energy. So here you see the potential energy and here you can see the kinetic energy. Now converting this velocity, we have a formula V is equal to root over G m by r, that is the relationship between the velocity and the gravitational force. Substituting this value here, you get kinetic energy is G capital M into small m by 2r, means this is the kinetic energy. Finally, this is the kinetic energy and this is the potential energy. So now we are asking the ratio between these two factors, means ratio between the kinetic energy and potential energy. So here you take the kinetic energy, this is G m by 2r, and if you take this is the potential energy G m by r. If you take, then you get the answer as 1 by 2, means the ratio between this kinetic energy and the potential energy of a body which is moving around the earth is half. So you can see the answer is 1 by 2. Next, what is the acceleration of a meteoroid passing by the earth at an altitude of 55,000 kilometers? If you consider the mass of the earth is 6.0 into 10 to the power of 24 kilograms. So he is asking about acceleration of a meteoroid. You know what is the acceleration? The rate of change of velocity. So here given, let us take the values. Given r is equal to 55,000 kilometers, as it is moving at an altitude of height, and we want to find out the acceleration of this object. As we know that according to a formula, F is equal to G into capital M small m by r square, that is according to the Newton's universal gravitational force, and according to the Newton's second law of motion, F is equal to mass into acceleration. So this both are giving with the same reference of forces, equating both, we get ma is equal to G into capital M small m by r square. When you consider this m and m as same values, then you get acceleration is equal to G into m by r square, where G is the acceleration due to gravity, which is a constant value 6.67 into 10 to the power of 11, and mass of the earth, which already we have taken according to this question, 6.0 into 10 power 24 kilograms, and altitude, that is radius, we have taken 55,000 kilometers, so 55,000 square. By simplifying all these values, you will be getting the answer called 0.1, meters per second square. So the answer here is what? 0.11 meters per second square. Means a body which is accelerating, means a meteorite which is acceleration passing from 55,000 kilometers height. Next question. Determine the gravitational action between two asteroids separated by 22,000 meters if their masses are 4,50,000 kgs and 7 lakh kgs respectively. So here if you observe, he is asking about the gravitational attraction between the two asteroids and he has given the distance between them and masses of two bodies. So let us see, taking these values, as we know according to universal law of gravitational force, F is equal to G into m1 m2 by r square, where G is the universal gravitational constant, m1 and m2 are the masses of two bodies, then d is the distance between those two bodies. Here the bodies are asteroids. So substituting the values, we know G is equal to 6.67 into 10 power minus 11 into 4,50,000 and 7 lakhs divided by d square, which we have already taken here, 22,000 square. So by simplifying all these values, you get the result is 4.341 into 10 power minus 8. So 4.341 we have taken as 4.3 into 10 power minus 8 newtons. So the force between these two asteroids will be this much newtons. Next question. How much is the gravitational force that keeps an artificial satellite of a mass 3,500 kilograms in an orbit around the Earth at an altitude of 4,200? Again you can see here what is asking, gravitational force. How much is the gravitational force that keeps an artificial satellite of a mass? He has given the mass of a body and in the orbit around the Earth at an altitude, means at what altitude the body is moving. So these are the things which are given. So let us discuss once again. So gravity at height h is given by the formula G dash is equal to G into R by R plus H whole square. So here we take these things, as the consideration. So G dash means gravity at height we call, and G acceleration due to gravity value, and R is the radius, and R plus H where radius and height of the body. Now given the radius of the Earth, we know that 6,400 kilometers, and the height at which the altitude is taking, as here we have taken this value, that is 4,200 kilometers. The next, as already you know, the G value is 9.8 meters per second square, and the mass of the body is already given 3,500 kilograms. Here you can see this. Now, first let us find the acceleration due to gravity. As per that, G dash is equal to acceleration due to gravity. As we said, G value, this is 9.8 into meters per second square, and R is the radius of the Earth we are taking, that is 6,400 kilometers, and R plus H we are taking, that is 6,400 kilometers plus 4,200 kilometers whole square. By simplifying all these values, you will get gravity is 3.57 meters per second square. Once we get 3.57 meters per, then we want the force according to the formula, force W, or we can say weight. W is equal to mass into gravity, where here gravity we are taken as gravity at height, m into G dash or G1, and what is the mass? 3,500 kilograms. And what we calculated here, gravity, this is the value, that is 3.57 meters per second square. And when you multiply these both values, you get 12,500 newtons. So finally, the answer here is 12,500 newtons. That is the force of gravity at which the body is moving. Next, let us say F1 is the magnitude of the force exerted on a sun by the earth, and F2 is the magnitude of the force exerted on the earth by the sun. Then we know according to the Newton's third law, according to the Newton's third law, the force acted by one object on the different object will be equal to the force acted by the same object in opposite direction. Means here you can see that the forces are equal, hence F1 is equal to F2, but both are acting in opposite direction to each other. Like we say that F12 is equal to F21, means the force acted by the first body on the second body is equal to force acted by the second body on first body. Next question. If the density of the earth